Welcome everyone. I hope you all are fit and fine at your homes. So students, let me start with the very first video for this chapter in which we will discuss about the state of objects like as rest, motion, and then further we will discuss about the distance, displacement and the relative forms, scalar and vector quantities. So let me move on the state of objects. So you can see a picture on your screen, and in this screen you can see 5 different pictures or 5 different position of the objects, or you can say the persons. So in the very first picture you can see a girl sitting on the floor. In the second picture you can see a person lying down on the floor. In the third picture, you can see an old lady sitting on the sofa. And in the fifth and sixth picture, you can see a person is in running or a boy on the cycling form. So, what these 5 pictures explain to us? These 5 pictures explain about the state of object. Like as in first 3 pictures, when a girl sitting on the floor, a person lying down on the floor, and a old lady sitting on the sofa, they all are in their state position or in the same position without changing their position. And in the fifth or sixth picture, where you can see a person in the running state and a boy on the cycling form, they all change their position with respect to time. So these 2 states that are rest and motion, we should know what actually they are. So let me start with the very first form, that is rest. So what the rest means? Rest means our object or body is to be at rest position if its position does not change with respect to a fixed point in its surrounding. Like as if we put something on a fixed position and its position does not change according to their surrounding, then this object is in rest position. Like as if we consider few examples, like as you can see on the screen, we have 3 examples. The first one is tools lying on the floor. If in the surrounding the tools is in the rest form, there is no changing in the position of tools till the person or someone else applied any force and tried to move it. So they are in the rest position. Same like as a bench in the park. If you move one day in the park and you can see a bench at some position, if the second day you move to the park, you can see the bench at the same position till that time anyone destroyed it or anyone removed it from there. Okay, so any object which is in their position will stay in the rest position till that time no external force applied on it to make the change in their position, and there is no applicability of time for changing this position. So let me move on the next form, that is motion. What is motion? Motion is a change in position with respect to time. Means in the rest form we are not changing the position. The position is same or at the fixed point. But in motion, the position of object will be changed with the respect of time. So let me see how it can be. If I can say you are moving from point A to point B, point A to point B, like let me assume that point A is your room and point B is your kitchen. So when you move from your point A, means your room, to kitchen, your position will be changed. Firstly, your position at point A is in your room. Secondly, at point B, your position is in your kitchen. So the position of the object means the position of yours is changed. And when you move from your room to kitchen, you will take some time. Okay. So here you can see the position of yours or your body is changed with respect to time. That is our motion. And when we talk about the motion can be described in terms of distance and displacement. So what is this distance and displacement? In the normal language, when I can say distance and displacement, distance is the total path covered by an object and displacement is the shortest path covered by an object. So what is the difference between total path and the shortest path? So for this explanation, let me move on this example. You can see a graphical representation on your screen. At here, you can see the blue line indicate distance of the object and the green line indicates displacement of the object. When we talk about the distance of the object, let me decide this is point A and this is point B. When we start to moving point A to B, we have two ways. Like as we will decide, in your room, you will have two ways to move to your kitchen. The one way says you have to move from your room to your parents' room to dining hall, then you can move to the kitchen. And the second way says you can move directly to the kitchen. So when you move directly to the kitchen, that is your shortest path. And when you move from your room to your parents' room to dining hall, then to kitchen, that is the longest path or total path of your. Yes, that is the total path. So when you take a long distance or long path, that is your total distance. And when you take a straight path or the shortest path, that is your displacement. There's one more thing, like as if I want to move from point A to point B, then there's this one direction that I can move like this or I can move like this. Okay, we have two directions. Whether I can move point A to B or whether I can move point B to A. There's only two ways. But when we talk about the distance, we can move like this. We can moving back to this. We can change the direction also. Sorry, we can change the distance and the length of the path also. We can take some movements and all. So means distance is the longest path and displacement is the shortest path. And displacement consider the direction and distance doesn't bother about the direction. You can take a round turn also on the distance, but you can't take, you can move like this. Means if you want to play and you want to move like this is your distance. But in displacement, you can't able to move like this. In displacement, you have to move in a straight path with a particular direction. I hope you all are clear about the distance and displacement. So let me move on some example of the motion. Like you can see the bullet trains, a car or anything, a ball, a person, anything which can change their position with respect to time are in motion. So now we have to discuss about the differences between distance and displacement. So distance, we already know the actual path or the total path during the motion of a body is distance, and the shortest path or the straight path is displacement of the object, or you can say the change in position made during motion of a body is known as displacement. Distance is a scalar quantity and displacement is a vector quantity. So what is this scalar quantity and vector quantity? Before starting this scalar quantity and vector quantity, I'll tell you that every physical quantity means those quantity which we can define in the form of physical phenomena. Like as motion. Motion is a physical quantity because we can experience these phenomena. So every physical quantity is described in the form of scalar or vector. Scalar or vector means whether they have magnitude or whether they have magnitude and direction also. So let me start with the scalar quantities and vector quantities. First of all, we will discuss about the scalar quantity. Every scalar quantity or every physical quantity is described under scalar quantity when it has a magnitude only. not bothered about the directions. So any physical quantity which has magnitude but no direction, that is categorized under scalar quantity. So what is the meaning of magnitude? When we talk about the magnitude, let me talk about your weight. What is your weight? Think about it. Okay, if I say an object which is 5 kg. Okay, the weight of the object is 5 kg. So here kg explain us that it's an mass, and 5 explain us the quantity of mass. Okay, so when we talk about the quantity of mass, this quantity is categorized under magnitude. Get it? Or should I take some other example? Okay, let me move on some other example. Like as if I write something and I didn't tell you which one physical quantity is this, you have to identify which one physical quantity is this, and then you have to identify the magnitude. So I will write in the first one, I'll write 25 meter, and in the second one I'll write 38 liter. So what it means? Meter, 25 meter, what it stand for, and 38 liter, what it means? What they want to explain us in the meter and liter? Yes, meter is the SI unit of length. So it means we are counting or measuring the distance of any object or any path. Okay, so in 25 meter, we measure the distance of any path. Got it? So meter means length and 25 means the, yes, this is magnitude. And liter means, exactly, this is a liquid, and 38 means, very good, that is magnitude. So means when we put any counting number with a unit of physical quantity, that is our magnitude. So which one physical quantities are categorized under the scalar quantity? Distance, very good. Yes. Mass, very good. Speed, very good. Now you can get some examples which we can count in scalar quantity. Let me move on the vector quantity. When we talk about the vector, now we will move on the vector quantities. Vector quantities we will have magnitude and directions. When we talk about the magnitude and direction, magnitude is clear to all of you. Let me talk about the direction. So when we talk about the direction, you can I'll take some example, like as if I say Ram is moving, this one is your Cartesian plane, and in this I'll indicate the direction north, south, east, west. Okay, so Ram is moving from this point to north direction and he covered 5 meter distance. So what it indicates? Distance 5 meter means magnitude is clear. This one is our magnitude and this one is our direction. So when we talk about magnitude and direction, this quantity is categorized under vector quantity. So I hope you all are cleared about the scalar quantity and vector quantity. When we talk about the magnitude only, means counting number with any unit, that is your scalar quantity. And when we talk about the counting number with its unit and a particular direction, then we categorize those physical quantities under vector quantity. So let me talk about some example you can see on your screen. Under scalar quantity, You can see distance, speed, mass, energy, density, power, length, area, volume, time, temperature, and work. Under vector quantity, you can see displacement, velocity, weight, acceleration, force, impulse, pressure, momentum, gravity, and drag. Thank you, students. I hope you all enjoyed this video. For the question and answers related with this video, you can follow worksheet 4 and 5. That's all for today. Stay home, stay safe.